Hi everyone, my name is Leon. My Z ID is z5210334. This is my student ID. And today I'm going to go over my results from the Understanding the Solar System experiment. So firstly, I will define Kepler's three laws of planetary motion. The first law is the law of ellipses. It states that all planets move about the sun in elliptical orbits, with the sun as one of the foci. The second law is the law of equal areas. This states that a line joining any planet to the sun sweeps out equal areas in equal periods of time. And the third law is the law of harmonies. This states that the squares of the elliptical orbits of the planets are directly proportional to the cubes, the semi-major axis of the orbits. So here are my answers for question 9 in the moon and planet simulation. You can see that, yes, the planet does move slightly in a circular motion as the moon orbits around it. In this scenario, the center of mass is located just outside the Earth. This is because the difference in mass between the Earth and the moon is not as significant as the ones we saw in questions 1, 4, and 7. In those scenarios, the difference in mass between the planet and the sun are much greater, and thus the center of mass is located near the center of the sun. So how is the planet-moon center of mass different from the sun and planet? Well, since the planet and moon have a much smaller difference in mass compared to the planet and the sun, center of mass of the planet and moon is just outside the planet. This explains why the planet moves and the sun doesn't. For question 11, I measured the distance between each marking using the measuring tape, and I got this result in kilometers. That equates to 0.4899 astronomical units, and we can round that up to 0.5 astronomical units. So for question 14, I picked 4 distances and tested the time it takes to complete one orbit. So for the first distance, it's 0.5 AU. The second one is 1 AU. Third one's 1.5 AU. And the fourth one is 2 AU. These are all my results collated in a table. So it takes 126 days when a planet is 0.5 AU away from the sun, and 365 days for 1 astronomical unit, 659 days for 1.5, and 933 days for 2. And do these results follow Kepler's third law? Yes, they do. The third law states that the squares of the orbital periods of the planets are directly proportional to the cubes of the semi-major axis of their orbits. The orbital period does indeed increase as the planet's distance increases. So for question 15, I expect Mercury to be the planet with the fastest velocity in the solar system because it is the closest to the sun, and Neptune to have the slowest orbital velocity as it is the furthest planet to the sun. And this is explained by Kepler's third law, which states that the orbital period of a planet is proportional to its distance from the sun. So planets that are further from the sun have longer orbital periods and slower orbital velocities, as the sun's gravitational force has less effect on planets at greater distances. Inversely, planets that are closer to the sun have shorter orbital periods and faster orbital velocities, as the sun's gravitational force is stronger the closer the planet is to the sun. Okay, now what did I learn from this experiment? Well, I learned Kepler's laws of planetary motion, and applying them to the simulations, I found out that the sun was actually really big compared to other planetary objects. Orbits are fairly circular, but they're actually elliptical. And I just understood how planetary objects behave around each other better through using different variables such as mass and distance. and just the sheer size of the solar system and how small we are compared to other objects in the universe. Thank you.